Hello everybody, Chris here, and in this video I want to show you guys how we can instance a object in a 2D game world in Godot at the mouse cursor, and then also check for collision to make sure we're not accidentally creating an object in, let's say, a wall. So I have this template scene here. If I run it, you'll see the character has basic physics, and we have walls with collision. That's about it. So in order to create an instance of the captain or any other object, we're going to need to create a new script in order to do that. So wherever in my game I'm storing the systems that are going to be controlling everything is where I would put this kind of thing. For right now, there is a level scene that I'm using. So I'm going to just add it to the level. But eventually it could easily be further up the hierarchy so that it's independent of the game level itself. So in order to instance copies of this captain, we're going to need a script in order to do that. So somewhere in your scene hierarchy, we're going to need to create a new node. So I'm going to right click and add a child node. So we'll just use a basic node for this. It doesn't even need to be a node 2D. And then I'll rename this. Let's call it something like object creator. And then I will right click and attach a script to it. So I'll go ahead and create this in the tutorial folder here, objectcreator.gd. Let's open and create. Okay, so if you'd like, you can give it a class name at the top, something like class name object creator. This just adds it to the node creation menu, so if you ever need it again, it's easier to just create from class name. Then we need to know what we're actually trying to create. So in this case, that's going to be a packed scene. So I'm going to export var. I can call it create scene, packed scene. This is going to be the object that gets created when we use the create action. Or let's say defined below. So the create action, what would that be? So in order for a button press to actually do something in a Godot game, you would need to define an action somewhere in project settings, input map. So you can see here, I went ahead and manually created a create action. So in order to do that, I could just say like create new object. You click add event over here is the plus sign on the right, and then you would press the key that you want to trigger the action. So that could be a keyboard press, a joystick button, basically anything that works as input. So I could just hit C for create if I want. And let's create that there. So you can click close. And then whatever that action name you created was, you want to add it in here. I'll do it as a export var action. So we can define it as a string name, which implies that we're going to just set it once. It's a name that doesn't really change. And then we write in the name here. So we could do create new object. As long as we defined that name up here and import map, it should work. And then we can press the button down here or just create if you prefer. Okay, and then we need to respond to that action. So we can get rid of the ready and process functions. Probably not going to need that. And what we do need is function underscore either input or unhandled input. So I'm going to use unhandled input. In the case that something else in the game, the UI, takes the action and already handles it, we don't want to respond to the action twice. So if nothing else handled the input first, then we will handle it through our object creator. So what we're going to do is take the event here. So the full function is function underscore unhandled underscore input. It takes an event, input event as a parameter, and it returns nothing or void. So we take that event and we want to check if it was the action we're actually checking for. So if event dot is action pressed, and this is going to take a string name. So we put in action up here. Now you can also manually type in the string name, but it's always kind of a little bit better if you pull it out to a variable rather than hard coding all of the strings necessarily. So I'm going to put action here instead, which means whatever we define here in the inspector is going to be the action we're checking for. Okay, so if the create new object action is pressed, then we want to try creating the object. So I'll create a new function, try create. And what are we trying to create? We're trying to create this create scene. So I'll just make it a parameter. So we'll pass in create scene. And now we need to actually create that function. So function try create. And we're creating from some kind of source on our project. We're creating an instance of it. So I think something like pSource works just fine as a name. And this is of type packed scene. So if we try to create, we want to return either null or the root of the object we just created. So in this case, it's a 2D game, so we're returning a node 2D. So in the process of creating an object into the scene, there may be collisions as we just instance an object and set its position. We'll come back to that in a minute, and there are multiple ways of handling that. But for right now, let's just get the object in the scene. So I'm going to create the instance by instantiating from the packed scene. So var instance, which is presumably a node 2D, because we're creating 2D objects, is going to be the result of pSource.instantiate. So this creates a copy of whatever the packed scene is, and then it will exist in the game as that copy. However, it has no parent initially. So when you just instantiate it, it's an orphan node. It doesn't exist in this hierarchy over here, which is problematic. You don't want orphan nodes generally floating around your game. For instance, if a node doesn't exist in the node hierarchy, then when you unload the level, it's not going to unload that node, and that's an issue. So we want to make sure it's somewhere in the hierarchy. So we need some kind of parent, and we can define that as another export. So at export var instance parent, and this can be basically any node 2D. Really, you can make it a you can even make it a regular node, but then it won't receive the positioning of the parent, which might be an issue. So I would stick to node 2D here. So this is going to be where you want to instance the objects under. The new object exists within the parent, so it unloads if the parent unloads. Okay, so now that we have this instance parent as an export var, we can use it down here. So instance parent dot add child instance. So this is just going to mean that if we set the level or a different object as the parent, that it will just become a child of that parent. Like water right here and background parallax, you can see are already children of level. So it'll be just like that. Okay, and sooner or later, we're going to want to return the instance. So just return instance, and that should get rid of the error messages. But we also want to make sure that when we instance the object, that it is instanced under the mouse cursor. So that's pretty straightforward to do. Let's get the mouse cursor position. So we're going to say var create position is equal to instance.get global mouse position. So any 2D node or canvas item is going to have this position. So for a 2D node, you can get the position in the 2D game world where the mouse is pointing at, and then we can use that to set its new position. So the instance.global position is going to be equal to the create position, and that should put it where it needs to be. So if we, let's go back to the 2D scene real quick. We can see in the object creator that we have some properties we need to set. So you need to assign a parent. Anything in the hierarchy that's a 2D node will work. So we could just make it the level where we just add any created objects as a child of the level. If everything is a child of level directly, that might become kind of a little bit messy. So you might want like a subchild, like characters or something like that. But we can just instance it under the level for now. That's the most straightforward. And then the create scene is anything you want to create. So let's quick load, and I have the Captain Clown Nose scene already created here. So I'll save that. You can just see inside the scene exactly what we're going to be creating, just the character body 2D, a collision shape, a sprite, and all of that will be instanced when we create a copy of the packed scene. So let's hit play, and I set C as the button for creating the object. So if I press C, we get a character. If I press left mouse button, which was my original create action, you'll see that that doesn't trigger because we're only checking for create new object action over here. So if I press C a bunch of times, then it's going to create at the cursor. Now, here's the problem, though. We're not checking for any kind of collision. So if I go over the wall, I can just press C here, and that's going to cause issues. The character body 2D is a physics object, and having physics objects stuck in your wall is no good. That's going to cause all kinds of issues. Also, if I create them where we already have a whole bunch of other characters like this, then you'll see we get some issues. So at the very least, we don't want to be instancing an object where it's already colliding with a bunch of stuff. So there are multiple ways of doing that. One example would be using a shapecast or raycast 2D to check the area under the mouse cursor before you instance the object. But a way I just tried out is actually to instance the object like we already have, and then check if it is initially colliding. If it is, we just free the instance we just created, don't allow it to basically exist in the scene, and we can print a message to the console if we have to delete it that way. Now, there might be issues with that because it already exists in the scene for a single frame, but I think it was working pretty good for a demo at least. So let's check collisions. Okay, so when we create this object, we want to pass it into a function which will check if there are collisions under the newly created object. So function check collisions, this is a custom one we're writing right now. And we're going to need to pass in the instance. So I'm going to do p for parameter underscore instance. This would be a node 2D. It's going to return a Boolean whether it is colliding or not. And we want to get a list of all of the physics body 2Ds that are inside of that scene and check them for collisions. And the captain knows our physics body 2D is actually the character body 2D itself. So if I was to, let's say, go into the search help and we search character body 2D, click on character, and then we look at inherits from physics body 2D, then you can see a physics body 2D can be either a character body 2D, a rigid body 2D, or a static body 2D. So we want to check any of these types that are there and see if they're currently in collision once it goes into the scene. Okay, so let's see here. We have the instance passed in. So we'll check all of the children of the instance and see if they are physics bodies. So let's get physics bodies is equal to the instance dot find children. We're going to put nothing for the pattern, just a empty quotations, so an empty string. But for the type, we're going to search physics body 2D. So this is going to mean that when it's checking children, anything that inherits from physics body 2D is going to go into this list of, or this array rather, of physics bodies. So it is an array. I can make it a little bit clearer by just putting that it is an array here by defining the type. And the thing about find children, though, is that it doesn't include itself. In this case, the clown knows the root is the physics object. So we want to also include the root. So that is an extra we can just add in here. So we'll check if p instance is a physics body 2D of some type, then we will append it to the physics body array. So physics bodies dot append, and that's going to be the instance itself. Okay, now that we have the physics body of the root and any children physics bodies, we want to loop through them and see if any of them are in collision. So for body in physics bodies, first we want to ensure that it is a physics body that we're checking. So we can manually check on each object of the array. Another option would have been to convert this to a typed array of physics body 2Ds. Either will work. I don't think you can just do this, though, where you type it initially like this, because find children returns a generic array, not a typed array. So you would need to take these and convert it. So it really doesn't help you anyway. But let's see. If body is physics body, yep, then we need to check it. So we'll say var is colliding. And that's going to be equal to the body itself. And we can do a test move function, test underscore move. So this takes the body and pretends like we were going to move it from a transform position into a certain direction, the motion 2D, the motion, which is a vector 2D, and then it would return any collisions that it would collide if it happened to make that move. So we're going to take the body's current transform, so body.global transform, and then we're going to do, let's see, vector 2, 0, 0. So the motion is no motion at all, actually. So it's just going to move into its same position, which is the global mouse position. And then if it's colliding, then we already know that there was at least one collision in putting this object into the scene. So we're going to return true here. Now, if it happens to loop through all of these bodies and it hasn't found any collisions, then after that, we can just return false. So to check collisions, we'll test each physics body 2D on the P instance and return true if there were any collisions in putting the object into the scene. So yep, there's our collision check method. And one of the handy things about this is that we don't really need to know the details about the object we're creating in the scene. So if we go back to the Captain Clown nose, so the physics body collisions is dependent on the collision shapes. I can make them way bigger or smaller. I can make them different types of shapes, right? And all of those are going to interact a little bit differently. But if we just test the move on the physics body, then we don't need to know any of the details about the size and shape of the collision shapes. We can just test the body as one unit here. And testing this way just means that we can check all of the physics bodies without needing to know the details. So basically, it's kind of like a one method will suit all. We don't need to increase the size of a shapecast 2D to become the size of the object we're trying to instance. We're just checking from the instance physics bodies themselves. So if we fail this method and we want to check that after we instance the object, then we can say if check collisions, and then we'll say instance. If there is a collision, then we want to free the instance. So I'm going to say instance.free. We can also print a message to the console. So that could be something like prints cannot create because object would collide at create point. And then I'll use a $$ here, which means that we want to replace this with a string. And that's going to be the create position. So we just replace this with the vector2 create position, and this gets converted into a string automatically. And if we are not returning the instance, then we are going to return null. We don't want to return this freed object because that can create other sorts of problems in the code. It's much better to just return null if we expect it to be nothing here. Okay, so we can go ahead and hit play here, and I'll hit C to create an object. It works in the air as we would expect, but if we go to the wall and I hit C to create, then if we check the output, then you'll see that we get that error message. It's not going to actually allow us to create the object there because it would be a collision. And I'll try it over here. So right there it worked, but if I go over the character itself, the existing one, then you'll see that that would be a collision as well. So just in the test move, when we're creating the object, it kind of puts that requirement in where we have to be putting it in a valid space. So that works pretty solidly, I think. So the only real issue I could see with doing it this way, where we create the object and actually it exists in the game before we check the collision, is that when you add a child as a node to another node, it is going to be triggering certain signals. So for instance, if I check the node documentation, I think child entered tree would trigger from this because add child had been called. For the most part, though, that isn't really going to be an issue. It's just something to be aware of, that we are adding that object as a child in order to test its collisions and then removing it immediately when it is done if it fails the collision check. So something to be aware of, but aside from that, a really straightforward way of checking collisions and instancing objects at the mouse position. So really from here, you would just want to basically figure out what you're creating if you have other objects you want to put in. So you could have like a UI that changes the create scene. You just have to target the object creator and change the create scene, and then you can create any other object you want during gameplay, as long as you change it to a valid packed scene. So for instance, I could just create something real quick here. Let's create a 2D scene. I will change the type to, let's say a static body 2D. And we'll need a collision shape 2D for that. So let's make it a rectangle. Give it a sprite 2D. And I'll create an objects folder. Okay, but let's see from the art pack. And this is Treasure Hunters by Pixelfrog, which is a free pack you can use. So let's see if there's something good in here. Okay, maybe a cannonball. So I'll put this image as a sprite here. We'll change the collision shape to a circle. scale it down a bit so it's more like the actual sprite shape. Might adjust the sprite position just a tad. And because a ball would usually have physics, I might change its type to a rigid body 2D. Just give it full physics. Okay, and let's rename it cannonball. Save it into the objects folder, cannon_ball.tscn. And now if we go back to the level, we can select our create scene. So I just go to create scene and let's quick load the cannonball. Now if we go hit play, we can hit C and there is our cannonball into the game. But if we try to instance over an existing cannonball, then you'll see, of course, that we have a whole bunch of error messages here, as we would expect. Okay, so there we have rigid bodies getting put into the game, and you can see these just have full physics. Works pretty well with a circular shape, as you can see. We might want to also say which type of object we are erroring out on here. So as a last thing, I will replace object with %s. Let's move the instance free below the print message. And then I'll add in the name of that instance. So we'll say instance.name, comma, because now we have two parameters we're passing into this string replace. And it's going to be an array here. So square bracket at the start, square bracket at the end. Let me just zoom in here a bit. So there's two strings we're going to be putting in, the instance name and the create position, which is a vector2 gets converted into a string. And we put that inside of an array with the square brackets. Okay, now if we hit play, and I click on the game, press C, then we're getting those objects instanced. If we go to output, then we can see, well, the name of that object would be created. You can see that the name feels kind of random here when it's getting instanced from those packed scenes. It doesn't have the name of the scene. So what you can actually do is grab the name from the source and then set that as the new instance name as well. So to get the name, we do psource.getState, and then we can get the node name. And we want the first node, which is going to be the root. So we get the name at position 0, and that's going to be our name variable. Okay, so after getting the name, I think the rule is you have to actually set it after it becomes a object in the scene. So instance parent add child instance, and then we do instance.name equals name here. We could actually just kind of shorten it. We don't really need a local variable, so we could just cut this, paste it over here, delete this line, and then when we hit play and we try to create an instance over here, we check the output and we can see that it has the name cannonball. So we create a bunch of objects, and then the next one is going to be cannonball 4 here because it's going to number objects that have the same name automatically. And you can see there's 3 cannonballs in the scene. So this would be cannonball 4. As I create more objects, that's going to increase the numbering. But that gives us more of an idea of what we're actually trying to create at the position rather than just saying object generically. So I think that's going to wrap up the video as is. I'm going to post a link to this mini project in the description so you guys can go download it. So until my future tutorials, which hopefully will be coming out very soon, I've been Chris. Thanks for watching to the end, and until next time.